Good morning everyone. Welcome back to 8th lecture on remote sensing and GIS applications for final year first semester BTech Civil Engineering students. In previous class we discussed about the sensors and platforms, different types of sensors based on the source of energy. They are classified into different types of sensors, active sensor and passive sensor. Then different altitude from the earth surface, they are classified into different types of platforms. One is ground based platform, second one is airborne platform, third one is spaceborne. So, ground based remote sensing, this is already I discussed in previous class. Just a recap once again. Ground based platform. See, ground based means ground based remote sensing system for earth observations, and it is used for earth resource studies, and it is mainly used for collecting the ground truth data from the earth surface. Without ground truth data, we could not interpret any satellite image. So, that is why ground based remote sensing is very important. Second one, airborne platform. See, in ground based remote sensing we are using cranes and handheld cameras. It is low level from the earth surface, and this is the airborne remote sensing. In airborne remote sensing, basically in generally it is used to acquiring the photographs and photo interpretation and photographic purpose, it is useful. So, in airborne remote sensing they are used aeroplanes, helicopter, hot air balloons, airships. These are all gives the photographic images and aerial photographs. Then spaceborne remote sensing. In this spaceborne remote sensing they are using shuttle and satellites. So, here spaceborne platforms include the space station as well as both low level means how much 700 to 1500 kilometer, and high level also up to 36,000 kilometer satellites. These type of platforms can acquire large area of data in a short amount of time. Within short amount of time, it capturing the large area, which can be used to monitoring earth resource, atmospheric dynamics and other applications. Other applications means some weather forecasting, natural hazards, environmental monitoring. So, different types of platforms used for different applications. One is spaceborne remote sensing, airborne remote sensing and ground based remote sensing. When compared to these are all, spaceborne remote sensing covers the large area within less time, up to 36,000 kilometer. So, this is the entire picture of platforms, so different elevation and different heights from the earth surface. These are all I already completed in previous class. Now, we are going to discuss about launching satellites, so now today we are going to discuss about basic terminology about the orbits. So, basic terminology about some satellite sensors, orbits and inclination angle, altitude, repeat coverage, ascending path and descending path, swath width, oppose. So, these are all some terminology. Before going to discuss about Landsat satellite, Indian remote sensing satellites and SPOT and NOVA, whenever the spacecraft is passing through the flight direction, it capturing the so much of radiation from the earth surface, then some altitude is there, some inclination angle also there, repeat cycle, how many days it is revisit time. So, before going to discuss about these are all, first you should know the basic terminology about what is orbit, what is low level orbit, high level orbit, these are all we will discuss today. Okay. First one, what is an orbit? An orbit is a regular repeating path. See, it is a regular and repeating path. So, it is a path. Orbit is nothing but a path. So, generally it covers the in particular one path. See, an object in an orbit, for example, if you have any object on the orbit, then that object is called satellite. An object in an orbit rotating, this object is called satellite. So, why the satellite moving around circular path? Why? Because see here, if you observe here, if an object is moving along circular path, means it acting two forces. One is gravitational force towards the earth surface, another one is centripetal force away from the earth surface. Gravitational force towards the earth surface, centripetal force away from the earth surface. These two forces are equal in opposite directions. Then the resultant force acting this direction. That resultant force is acting perpendicular of these two forces. That is why the object is moving in this direction. You see, this black is moving direction, red is gravitational, the earth is pulls towards the, due to the gravitational force, this force acting towards the earth. So, at the same time the centrifugal force also means action is reaction, both are same forces, same intensity acting in opposite directions. That is why the resultant force acting perpendicular of these two forces. This is the resulting force. That is why the object is moving around the circular path. So, here the satellite is can be natural like earth and moon. Many planets have moons that orbit, that is why this is the complete picture of the orbit. Next one, different types of orbits. Different types of orbits present in the around the earth surface. First one, if you see this blue color nearer to the earth surface, that is low earth orbit, and there are certain satellites that are placed in medium earth orbit. This is if you see, this is the medium earth orbit. So, this green indicates there are some satellites are presented in the medium earth orbit. This is called MEO, low earth orbit. It is nearer to the earth surface. This is the LEO. This is green indicates the MEO, medium earth orbit. Then geostationary orbit, and this is the red indicates HEO, highly elliptical orbit. This is the elliptical. That is why just if you see this, this is not a circular, red is not a circular, some elliptical path. That is why this is the highly elliptical path. This highly elliptical orbit is always nearer to the moon planet. It is always nearer to moon orbit. That is why regularly we for example, we placed the Chandrayaan 2, that particular spacecraft, in multiple achieves. So, that rotating across this, whenever they are launching the Chandrayaan 2 passing in this orbit, it goes to like this, and a highly elliptical part and some distance. In this distance the moon orbit also there. That is why when it needed to moon orbit, then it transferred to moon orbit. So, just it pushed to moon. That is why the Chandrayaan 2 satellite passing through this orbit. This is HEO, highly elliptical orbit. Then geostationary orbit. This violet is geostationary orbit. Green is medium earth orbit. Then LEO is near to the earth surface. This is low earth orbit. What is GTO? T means transfer, geo transfer orbit. This geo transfer orbit, why we are using this geo transfer orbit? Next slide I will explain to you. So, nearer to the earth, some high level, low level, medium level, like that. Based on the altitude, they are classified into different types of orbits around the earth surface. In this orbits, so many satellites daily monitoring earth surface. One is LEO, low level earth orbit, high level elliptical orbit HEO. GTO means geo transfer orbit. Now, what is GTO and what is GEO? What is the difference between these two? Basically, GTO means this is the earth surface, this is the earth surface, this is the geo transfer orbit, this is the geostationary orbit. This violet is geostationary orbit. See, we are launched a particular satellite. This is for example, this is the planet, this is the earth surface. For example, India, Sriharikota. If you assume in India and Sriharikota, if they are launched any satellite from that area, directly it go to they are kept inside that object, they are kept inside in the geo transfer orbit. So, the satellite is carries with particular launcher. So, this launcher carries a satellite at particular orbit, that orbit GTO. So, it is placed in particular orbit. The launcher carries the platform, then the launcher is placed in a particular orbit. Once it keeps in a particular orbit, for example, once it keeps in particular orbit, it moves in a same path. See, it moves in a same path, in this path like this. Why? It does not require any energy, it has some energy. So, why? Because it is balancing with the gravitational energy. Whenever it enter into the orbit, it has some energy, some balancing energy. Satellite speed is equal to the gravitational speed. Then these are balanced each other, then the path of the object is circular. So, then the platform is going to like this. So, it rotates nearer to the earth surface, nearer to the earth orbit. One particular satellite comes to this position. See, at particular in this position, when the particular satellite come to in this position, see, in this position, we boost them, we boost it. Then what happened? See, the original method to boost ComSat, this is one type of satellite. So, Landsat or IRS, CamSat. So, any satellite they are going like this only. They are launching, they put it the satellite in the orbit. Whenever the satellite comes to in this position, we boost it up to transfer into second orbit. See, this is second orbit, this is the first orbit. The satellite is passing through this orbit, and when the satellite come in this position, just we can give some energy to that satellite, then it transfer to one orbit to another orbit, then it goes to geostationary orbit. So, this is called, in this position the satellite is transferring one orbit to another orbit. That is why this orbit is called geo transfer orbit. This red orbit is called geo transfer orbit. By using geo transfer orbit, satellite always transferring from one orbit to another orbit. Like that, the satellite goes to geostationary orbits, rotating around the geostationary orbit. So, GTO, it is just to transfer the particular satellite from one orbit to another orbit. That is the GTO process. That is why it is called geo transfer orbit. I hope you get this too. Next one, what is the polar orbit? This is the polar orbit. So, this is the polar orbit. In this polar orbit, the satellite passes close to the geographic poles, north pole and south pole. It passes near to the close to the geographic poles, and around the pole this particular satellite will rotates. Means from north pole to south pole, generally it rotates within 90 minutes. It rotates around the earth pole. See, so it is kind of a low level earth orbit. It is nearer to the poles, nearer to the earth surface also. It is located by 100 kilometer to 1500 kilometers. Within this range, polar orbit is located. So, remote sensing satellites are placed in the particular orbit. So many remote sensing satellites are placed in this particular orbit. Nowadays, Rs&Gis and NOVA, so many satellites are passing through this orbit. This is the polar orbit. Then geostationary satellite. See, this geostationary satellite are placed in general over the equator. Over the equator, the satellite is placed. This is the equator, east to west, west to east. So, this is the equator. In the case of polar is north to south, but here equator. Why it is used? The name itself says that, just you see, geo and stationary means earth at one point of time. Earth at stationary means constant at one point of time. It constantly it is capturing the radiation. If you are looking at this particular satellite, see what happened. So, whatever point of time you look, it will be there. But in polar satellites, once you are look up, it will be there. So, only after 90 minutes it can see again in polar orbit. But in geostationary, not like that. Let us say you are located here, for example, you are located here, then in the satellite rotates along with you. Why? Because earth also rotating, satellite also rotating, earth velocity and satellite velocity are same, then it is rotating stationary around the orbit. That is why this is the geostationary. So, this is geostationary satellite. For example, whatever the object is placed in the satellite, that object also rotate with the earth surface velocity. So, both are rotated with same velocity, that is why it is constantly observing at one point of time. So, that is called geostationary. It is located around 35,000 kilometer to 36,000 kilometer. It is rotated around equator of the earth, and it is rotated west to east poles, rotates same speed of the earth, and communication satellites and weather monitoring satellites in this orbit, always passing through this orbit. GEOS, Meteosat, and INSAT, Intelsat. So, this is the geostationary orbit. Geostationary orbit means constantly the satellite is monitoring one place. So, with this is always rotates with speed of the earth, that is called geostationary orbit. So, geosynchronous orbit. What is geosynchronous orbit? Geostationary orbit located approximately 35,000 kilometer to 36,000 kilometer. In this height, the satellite are placed. In the case of geostationary, in the case of geosynchronous also placed at a particular object, the height is 35,000 kilometer to 36,000 kilometer. So, similar to geostationary orbit, here also communication satellites are placed, different types of communication satellites are placed in this geosynchronous orbit. So, what is the difference between geostationary and geosynchronous orbits? There are some differences there. What is the difference? The difference is that it is not directly above the equator. See, geostationary orbit always rotating around the equator. If see, this is the equator, east to west, this is north to south, this east to west. Geostationary is the equator. The geostationary, which object is rotating around the on the equator, that is called geostationary satellite. So, just what property as same properties also apply to the geosynchronous orbit, but it is just slight difference. It is not directly above the equator, just some difference, but different planes. This is x plane, for example, this is x plane, this is the y plane. So, both are some difference is there, but different planes, different paths, similar to geostationary, except that it is not on the equator. It is not on the equator. So, here we can have many geosynchronous orbits, but only one geostationary orbit is exactly above the equator, that is only. Then if you see, if you observe here one angle of inclination, the difference, the angle between geostationary orbit and geosynchronous orbit is called angle of inclination. So, this geosynchronous orbit, the satellites are covered entire globe, the regular basis, and give repetitive coverage on periodic basis. All remote sensing resource satellites may grouped in this category. Same communication satellite and weather monitoring satellites, all satellites rotating in geosynchronous orbit. So, this is the difference between geostationary orbit and geosynchronous orbit. Next one, satellite orbital characteristics. What is the some characteristics? Orbital having some characteristics. So, altitude, inclination of angle, and repeat cycle, ascending path and descending path, and opposed swath width and perigee. So, What is altitude? If you observe here, this is the distance from the earth surface. This is satellite passing through the orbit, rotating through the orbit, or this is also called flight direction. This line is also called, white line is also called flight direction remote sensing. They are used. So, inclination angle means, this is the inclination angle means the angle between orbit and equator. This is the orbit, this is the equator. Like this also we can define the angle between the orbit and equator. The distance from the satellite to the mean surface level of earth, this distance is called altitude. Then ascending pass and what is descending pass. So, for example, ascending path, so this is ascending path. Each orbit of a polar orbiting satellite will have ascending path. Ascending path, when the satellite moves, see, when the satellite moves from north to south, northward towards the equator, then that is northern hemisphere. Then descending path, when the satellite pass towards the southward, then it is called descending. They cannot cover high altitude. Why? Because they are used for weather forecasting and satellite, TV and communication. In this purpose they are using. So, ascending path means ascending path when the satellite moves northward towards the equator, then into the northern hemisphere. So, this is southward is descending path. Then what is oppose? What is Rs? If you observe here, see, this is the long distance from the earth surface, this is the short distance from the earth surface. Just you can observe here, this is blue is earth, is this is the oppose, this is the Rs. So, it is a point. How to define this? It is a point in the orbit where an earth satellite is close to the earth surface, that is called Rs. It is a point in the orbit where the earth satellite is farthest from the earth, it is away from the earth, farthest, long distance. This is called appears. These are 2 points, they defined like this. At its Rs, it appears 14% is larger than 30% brighter. It is always opposed always towards the sun. It is away from the sun. This point away from the sun. This is towards the sun. So, till now we discussed about the major terminology of orbit and satellite, and these are all synchronous and unsynchronous. These are major basic terminology. By using this terminology, we can study about the satellites. When the satellite is launching from the earth surface, whenever the satellite is rotating around the orbit, it has some altitude, some frequency, some wavelength, and some oppose, and which orbit, low level orbit, high level orbit, and geo transfer orbit, how the satellite is passing through the that orbits, we will discuss later. That is why this terminology is very important. Next one, we discussed about the resolutions and satellite launching dates, when the IRS series, Landsat series, Spot series, MODIS. These are all satellites and sensor specifications. Now, the major satellite systems. You know very well, spatial resolution. Based on the spatial resolutions, they are divided into 3: low, medium, high. High spatial resolution QuickBird icons, Orb 3, Spot 5, Palm, IRS P6. Medium spatial resolution Landsat 5 thematical mapper, Landsat 7 ETM, Aster, Spot. Low resolution. So, low resolution sensors is MODIS, Envisat, MSS, HR. So, these are all different based on the spatial resolution, they are classified into different satellites. These are all we will discuss in detail in later classes. Next, the basic terminology of imaging systems. Today, these are all we will discuss about what is the along track direction, what is across track direction, swath with dual time. These are also most important to understanding about further classes. What is direction of flight, how the sensors are scanning, and how much of area swath covering the satellite, how much amount of time camera shutter open for each image. This is a detail I will explain the later next class. Please, you can watch my next video for next class. Thank you.